Alright, what's up? It's your girl Aquafina here, and today we're gonna prove the birthday problem. Now, I'm sure a lot of you have heard about this problem before, but for those of you who haven't, here it is. Say we have a room of 23 individuals. They're not related in any way. Frankly, they could even be complete strangers. Now, in this group, we want to know what the probability is that at least two of them share a birthday. Now, believe it or not, the answer is actually 50%. Now you can go look up the math behind it and all, but you might still struggle to wrap your head around it, which is understandable. So, how do we make this simpler for us to understand? Well, Monte Carlo simulations are here to save the day. We're going to write a program in Python proving this answer using Monte Carlo simulations. Alright? So, when we're working with random numbers, we always want to start with import random. Right? Now we're going to make a function that is going to compare the birthdays. So we're going to have an empty array. We're going to start off with an empty array, and then we're going to use this for loop to add in birthdays. Just random birthdays. How do we do that? Well, we're going to append it, and we're going to do random.randint, which is going to give us a random integer between 1 and 365. Now, to keep it simple, we're not going to use leap years at all. We're just going to use a regular year with 365 days. And let's say for this case that January 1st is 1 and December 31st is 365, all right? So now what am I doing? I'm making nested for loops, which are going to compare each of the values, right? Now what happens if it ends up finding a pair of common birthdays? Then the function is going to return true. Otherwise, the function is going to return false. Now we're going to have a variable telling us the number of simulations we want to run. Now, this depends on your computing power, how fast you want to get the results, but we still want it to be a large number. So a safe number for me is 5,000, all right? So this for loop, we're writing this for loop because we want to estimate the probability between 2 and 40. We're starting with 2 because if we start with 1, then this function won't work since it needs to compare at least 2 birthdays, all right? And what we're going to do is we're going to have a counter here that'll count how many common birthdays it finds through the simulations. Right? So now we're going to have a loop that's going to loop every single simulation. And if the function ends up returning true, meaning it has found common birthday pairs, then we're going to increment the counter by 1. Okay? Now, what we're going to do is we're going to evaluate the probability, the estimated probability, which is just the counter divided by the total number of simulations. Now we want this to be a float. Otherwise, it's going to evaluate to 0 because it's an integer. So it is rounding down to 0. Alright? Now, lastly, all we do is just print it. Okay? Now, this might take me a while because I'm trying to come up in my head how to organize this, but we're going to separate it. We're going to show how many people are in each room first, and we're going to write the probability of a common birthday in the room is equal to, and then display the value right here. Okay? And since we multiply it by 100, we're going to put percent. Right? Now let's run it. And let's see if we get an answer close to 50. Here we are, right here. 23. That's the first case in which the number steeps above 50%. All right? Now just to confirm it, we can put an even bigger number. I'm going to put 10,000 just to get a more precise answer to confirm it. Let's run it again. Right, here we go. There it is. 23, 50.81%. So, we have proved it. Now, alternatively, I think this is a lot cooler, but if we go all the way down to 40, then it actually gets really, really close to 90%, which honestly I think is cooler than the 50% fact. But overall, this is the original answer we are looking for, and so we have proved the birthday problem using Monte Carlo simulations.